What's good, guys? Today we're going to be solving climbing stairs. This is a dynamic programming problem, and I do know that that programming problems tend to be a bit harder. So let's see how long it's going to take for me to solve this. I know you got to find like a base case and work from there. Let's see. We're given an integer n representing the number of steps to reach the top of the staircase. Okay. You can climb with either one or two. Okay, so let's see. We can either use one or two steps. We are given n, which is the total amount of steps we have to take to complete. Okay. Okay. So input is n and output is 3. Okay, so 1 plus 1 was 3. Oh, okay, so we're counting the reversal as another one. Okay. Return the number of distinct ways. Uh, okay, let's go ahead. I think we could have like a base case. And you gotta define a function called okay, we'll give it the number. Okay, let's call it stairs left to see how many stairs are left. I'll return an integer. And I think we should have the base cases. If stairs left is equal to 2, we go ahead and add that as one case. Stairs left is equal to 2. We could go ahead and return, I think, um, we could increment something. No, no. If stairs left. Now let's see. This is definitely wrong. I gotta return something else. So if I give it like 10, see for example, if I give it 3, if I give it 3, let's say stairs left is not equal to this, it's not equal to that. I think this is where we have like a tree. We have like a tree where it goes like option 1 would be go take option 1 take 2 stairs, 2 take 1 stair. So what is equivalent to taking 2 stairs? Oh, wow. I think dynamic programs always breaking the problem down to smaller problems. So if we're given a big problem like 3, how do we break this down to sub-problems? We have an option where we add 1. All right, I'm gonna go for a hint. Memoization. Okay, we can use memoization to avoid repeated work. Create an n-sized array cache to store the results of recursive calls. Create an n-sized array. Okay. Called cache. Store the results of the recursive calls. When the recursion is called, specific parameters. I think that's definitely a hash map. Cache would be equal to n-sized array. How would I create an n-sized array? Why would I need to create an n-sized array? What do we want to return? Do we want to return an integer? I think we should return 2 things, man. Stairs left and count. Steps taken. If it's greater than 2, what do you want to take? Alright. Base condition to stop the recursion. I think the base condition to stop the recursion would probably be when stairs taken is a negative number or 0. Oh god, I don't know how to solve this one. I have to look at the solution. Recursion, dynamic from top down, bottom up, space optimize, matrix exploration. A lot of different solutions, huh? Let's go with recursion. We have 2 choices. Okay. From any step I, the number of ways to reach the top is I plus 1. Okay, that's what stairs taken is for. Then exactly on step N, that path counts as one valid way. That path counts as one valid way. Okay, if we cross N, it's an invalid path. What do you mean by cross N? This is also a classic example of exploring all possibilities using recursion. Okay, algorithm, we start from step 0. Okay. Okay. Is equal to N. If index, so for an index 3 and N is equal to 3. I'm not really understanding this comparison, but return 1, valid 1. Okay. Okay, if index is greater than N, 0. This makes sense because index could never be, right? Right? Because N is, you take a, oh wait, you got 3, right? Take 1, 1, 1, 1, 1, 1, 1, that's 3. Okay. Return the sum of both choices. Okay. This means that you're taking one step. Because we call depth first search with index being 0. But 0 plus 1 equal to 1. Return 1. So we know there's one unique. Depth first search index is 2. Say n is 3. Alright. So if n is 3, index is still going to be 1. I. We didn't even tell him what index is though. Index is going to be the number. It's going to be n. So 3. So depth first search 3. 3. So 3 is greater than n. Now it's equal. What? I'm so confused. Okay, wait. Okay, whatever. Let's go complete the question first. Oh, did I even make this correctly? Return the sum of both choices. Okay, hold on. Depth first search I. If I is greater or equal to n, return I is equal to n. Whoa. So if I is greater or equal to n, okay, let's say I put 3 in here. Return depth first search 0. Oh shit, let's return 0. Okay, so depth first search 0. If I 0 is greater than n, return I is equal to n. It's not. So 0 plus 1 plus 0 plus 2, that's 3. And see, 3 is equal to n, return I is equal to 3. Okay. Wow. So we define a function, we just give it 0. Damn, that's crazy. This solution, and we 0, no matter. Okay. Square. Nx is greater or equal. I'm not even gonna look at this. If nx is greater or equal to n, Otherwise, research. It's exploring every path. And now we just call it depth first search with 0. Hide and see. So if we give it 0, let's say this case. Okay, so let's put in 0. Index is 0. It's not greater than 3. So we return depth first search index of 1. 0 plus 1. So that's 3. So 3 is greater than or equal to n. So we turn indexes equal to 3 different ways. Okay, what if it's 4? So that's 3. So it's not, right? So we just do this again. Okay, wait. So if I run 4 and then it's 3. Okay. If I run 4. So this is third iteration. So it'd be index is equal to, let me think. So we start with 0. So 3 now becomes, this is, we put 3 right here. Wait, oh my God. Okay, 0. So we go straight to this. 0. This. Okay, that's the first run. Damn. Ah, okay. Damn, I got a gap on my recursion. Okay. Recursion. No. There's I plus one. Uh, Research one. One brings you to two. Four. So two brings you to. Okay. Wait. Oh.
Tongue-tied, I can't find no words to describe everything that you are. Swept up the rest of your love, don't budge, build a bridge to my heart. Your eyes are like the sun on a day that's cold. Your love is like a blanket around.
Okay, I get it now. I think I get it. I think this is it. This means that we reached the top. This means that we overshot. Interesting. So let's say it's equal to 4. It's 2. I get it. When it runs true, Why not put the cache first? Let's see if it works. Okay. That's why. Okay. I think this question really taught me a lot about dynamic programming. Okay, let me see my key takeaways from this problem. True is equal to 1. This one returns 0. This is how you make this length n to -1. This checks if we've seen and then if we've seen it, we can just skip the steps. For example, if we have 3 and we've seen 3 before, we just return whatever is right here, but if we haven't seen 3 before, we go ahead and compute it ourselves. Okay, I think that's it. Look at the other problems.